Alright folks, we're on number 4 about Morton Anderson and the kicking the field goal problems. A couple things you should know from reading the problem. The 18.5 that's in that diagram, that is described as the length of the arc. So we know that that's going to represent our S. We already know that particular measurement, that's in yards. That also told us that the radius was 50 yards as well. And what we want to find then is the maximum number of degrees that he can deviate from the intended trajectory, meaning that he wants to kick that particular football right down the middle. That will be his goal. Okay? But if he's off a little bit, if he kicks it a little bit to the right or a little bit to the left, how much of an angle does he have before he misses that field goal? Okay? So what we're going to do is we're going to look to the sides of those angles. That's my goal. Now, if I look at what's given down here, it looks like we've got enough to start working with that arc length formula. S is equal to theta times r. We already know that the S is 18.5, and we don't know the angle, but I know that that radius is 50 yards. Now, this one's easily solvable. Okay? I can take 18.5, and I can divide it by 50. Okay, we get about 0.37. Okay, but what you need to remember, folks, is that 0.37 is in radian. Sure, it's an angle. It is in radian. That is correct. But the problem asked us to find the number of degrees. If you look at that last line, the maximum number of degrees. Okay? So I'm going to have to convert that out of radian and into degrees. So I use my conversion factor of 180 over pi. Let's see if we can figure out what that is. 0.37 times 180 divided by pi. Okay, it looks like about 21.19. Actually, that would round up probably about 21.20. And then here's the tricky part. That angle that you just found represents this entire angle here. Because if this is going to be my curve length and this is my radius, okay, that angle belongs to the entire sector. Now, if he's going to deviate, that means he can come a little bit to the right, a little bit to the left. So I need to divide that in half. So I can say that he can go so much to the left, so much to the right. So the 21.02, if I take that and divide it in half, okay, or divide by 2, what we figure out then is that he's got 10.6 degrees, right, that he can deviate from the left or to the right and still be able to get it in between those goalposts. Okay, so each of these thetas right here, each one is about 10.6